Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have this is nice exponential equation 2 to the power of x plus 4 to the power of x plus a to the power of x is equals to 39, and we solve this problem for all the values of x. So here first we find all the roots of this equation, and at the last we will be verified that which of the roots are solution and which of the roots are extraneous root. And now we first rewrite this equation as this is 2 to the power of x plus this is 4, we write it as 2 square and its whole power x plus this is 8, we write it as 2 cubed and its whole power x is equals to 39. And now in the next step here, we just use the nice exponential rule, and according to this we interchange both of these two exponents and we get 2 to the power of x plus this will becomes 2 to the power of x whole square plus this will becomes 2 to the power of x whole cubed is equals to 39. And now here you see that the base of each of these terms are same, so we will take here m is equals to 2 to the power of x. So when we take m equals 2 to the power of x, so this will be written as m plus m squared plus m cubed, and here we move this 39 to the left hand side and we get minus 39, and this whole equation is equals to 0. And now further here we break this value as and we rewrite this term as m cubed plus m squared plus m and minus this is 39, we write it as 27 plus 3 plus 9, and this whole equation is equals to 0. And now here we rewrite this equation as m cubed plus m squared plus m minus we multiply this negative sign on each of these values and we write this 27 as 3 cubed minus 3 minus we write this 9 as 3 squared, and this whole equation is equals to 0. And now in the next step we make the pair of cubic term with cubic term and square term with square term, and we get m cubed minus 3 cubed into plus the square terms are m squared minus 3 squared, and the terms of power 1 are m minus 3, and this whole equation is equals to 0. So here we use the nice cubic and square formulas, and you know about that. If we have a cubed minus b cubed equals to a minus b times of a square plus ab plus b square, and on this term we use this formula a square minus b square equals to a minus b times of a plus b. So here we use both of these two formulas to the above equation, and this will be written as in this form. The first factor is a minus b. We have m minus 3 times of m square plus m into 3 plus 3 square, and plus the second factor is m minus 3 times of m plus 3, and here the last factor is m minus 3, and this whole equation equals to 0. And now in the next step each of these terms involve m minus 3, so we take common m minus 3 from here and we get the remaining values are m square plus 3m plus this 3 square becomes 9, and from here we get m plus 3 and plus from here we get 1, and this whole equation is equals to 0. And now we rewrite this equation as m minus 3 times of m square plus 3m plus m becomes 4m, 9 plus 1 10, 10 plus 1 becomes 13, and this whole equation is equals to 0. And now further in the next step here we need more simplifications here, and now first we divide this equation into the two cases. The first case is we get m minus 3 is equals to 0, and the second case is we write m square plus 4m plus 13 is equals to 0. So from first case we easily get the value of m is equals to 3, and here we back substitute the value of m, and you see that our m is equals to 2 to the power of x. So when we put this value of m here, we get 2 to the power of x is equals to 3. And for the values of x, we apply log on both of the sides and we get log of 2 to the power of x is equals to log of 3. So further we have here, we use the property of log and we move x in the front of this log, and this will becomes x times of log 2 is equals to log of 3. So we easily get the value of x is equals to log of 3 divided by log of 2, and we write this term as x is equals to log of 3 with base 2. So this is the only one value of x which we get here in this method. And now here we move towards our second case, and our second case is this. Here we use the quadratic formula to solve this problem, and for this we write the coefficients of this equation, and these are a is equals to 1, b equals to 4, and c is equals to 13. And we state the quadratic formula as m is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is the our quadratic formula. Here we put the values of a, b, and c, and we obtain m is equals to, this is minus b becomes minus 4 plus minus square root of 4 square minus 4 times of 1 into 13, and it is divided by 2 times of a, and here our a is equals to 1. And now further in the next step, we need more simplifications here, and we get m is equals to minus 4 plus minus square root of 4 square becomes 16, and 4 times of 13 is equals to 4 3s are 12. We write 2 and carry 1. 4 1s are 4 plus 1 becomes 5, and it is divided by 2 times of 1 is equals to 2. Further we have m is equals to minus 4 plus minus a square root of, so here we get minus 36, and it is divided by 2. So here when we apply the square root on both of these two terms, we will get m is equals to minus 4 plus minus square root of 36 into square root of minus 1, and we just break this 2 separately on both of these two values. And now here we have, this will becomes 2 times 2 is 4, and we have minus 2 plus minus, we know that square root of 36 becomes 6 and square root of minus 1 becomes iota, and it is divided by 2. So this is 2 times 3 becomes 6, and we get m is equals to minus 2 plus minus 3 times of iota. So these are the two complex roots of the given equation, and here we back substitute the value of m, and we get 2 to the power of x is equals to minus 2 plus minus 3 times of iota. So we again apply the log on both of the sides, and we get log of 2 to the power of x is equals to log of minus 2 plus minus 3 iota. So we move x in the front of this log, and we get x times of log 2 is equals to log of minus 2 plus minus 3 iota. So we divide this log 2 to the right hand side, and it will becomes x times of log minus 2 plus minus 3 iota divided by log of 2. So finally we have, this will becomes log with base 2 is minus 2 plus minus 3 iota. So these are the other two complex roots of the given equation, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting and interesting videos.